Hello guys, welcome to Solving Solutions, your number one channel where you get solutions to all your solving problems. It's nice having you in class again today. How have you been? We are going to look at a question in mathematical competition. It's actually a question on matrix, and then you can have it in your exams. Actually, it was gotten from Surveyors Council of Nigeria. It was gotten from the Surveyors Council of Nigeria examination questions also. So they said given the following equation. So if you're coming to the channel for the first time, you can encourage us by subscribing. And if you're a returning viewer, thanks for always checking up on us. So given the following equations, we have x plus 5y plus z equal to 14. We have 2x plus 3y plus 4z equal to 20. Then we have 4x plus 3y plus 2z equal to 16. They said we should use the inverse of a matrix method to find the values of x, y, and z. You know, this is actually a simultaneous equation, and then we have three unknowns, x, y, and z. And there are different methods you can use to solve this kind of simultaneous equation. However, we are using the inverse of a matrix method. Now, to extract some information from the question, we have to make reference to some known facts. So remember the general notation when you have a matrix, when you have two matrices rather, or let's say when you have an equation and you want to get the matrix out of when you have equations when you have equations and you want to form matrices out of it, you have something like ax equal to b. Now what does the a represent? A is actually the matrix representing the coefficient. Now what's coefficient? You know, basically in mathematics we already know that the coefficient is actually the number in front of the unknown. That's just a simple explanation of what coefficients are, right? Good. So for this, the coefficient of y in this first equation is 5. The coefficient of z there is actually 1, because you know any number that is 1, they don't use to write it, or it's not usually written, right? Good. So the coefficient of x here is 2. So that's what the A matrix represents. It's actually the matrix of what the coefficient. So as you can see here, we've actually extracted what the different coefficients. So we have 1 5 1, which is actually what 1 5 1, then 2 3 4, which is actually what 2 3 4, which is actually what 2 3 4, then 4 3 2, which you can see 4 3 2, right? Good. Then the next one is the x matrix. Then the x matrix represents the variables of the system. Variables sometimes are the unknowns, or they can also be seen as what the unknowns. So you know that we have three unknowns, as we've said, a simultaneous equation with what three unknowns, right? Good. So the x matrix represents the variables of what the unknowns of the system, or the variables of the system rather, right? Good. Then the b matrix is actually the matrix representing the constant. The constants are those numbers you have outside the equation sign, or outside the equality sign. Let's use that. They are the numbers you find outside what the equality sign, after the equality sign. So we have 16 20 and then what 14 20 and 16, right? Rather, we have what 14 20 and 16, right? Good. So you can see that we have three matrices here. We have a 3 by 3, then we have 1 2 3 1, which is 3 by 1, and we also have a 3 by 1, right? Good. So we have three matrices here, and then we've actually gotten from this our general notation, we've known the elements of each of those matrices, right? Good. Now the first thing we need to do now is that we need to find, or we need to determine the inverse of matrix A, which is this our matrix. And what does matrix A represent? Matrix A represents what the matrix of what the coefficients, right? Good. So we need to determine the inverse of A by augmenting with the identity matrix. Now this augmenting is something that is a bit new, that not really new, but it's new in this particular context. So what do we mean by augment? That's what we've actually given a representation here. So by augmenting, it simply means we are trying to join the two matrices in a particular square bracket, right? Good. That's just the simplest way. And now what is the second matrix? The second matrix is what the identity matrix. the identity matrix, which has all the diagonal elements to be 1 and every other element to be what? To be 0. So you can see the diagonal element here to be 1, and then every other element of that matrix is actually equal to 0. And you have 3 here because this is actually what? A 3 by 3 matrix, right? Good. So if this is 4, then we're having a 4 by 4 matrix, and most times they are square matrices, right? Good. So if it's 2, we have what? A 2 by 2 matrix. So from this note, we need to determine the inverse of A, which is our matrix of coefficients, by augmenting with the identity matrix. The equivalent identity matrix is actually what? A 3 by 3 matrix, which we've actually written here, right? Therefore, by augmenting, we have this our A matrix augmented with what? Our identity matrix, right? Good. Now at this point, you need to be very attentive. The idea behind it is that we want to turn, let's call this the left hand side. We want to turn the left hand side to look like the right hand side, thereby making the right hand side to look like the left hand side, which simply means that by the time we are done with this row reduction, because that's the process we want to start now, by the time we are done with this row reduction, the elements we have here will look like this. In fact, the elements we have here will be what? An identity matrix. Then the elements we have here will be a normal 3 by 3 matrix, and the elements of this matrix actually represent what? The inverse of this our A matrix. You are going to see how interesting that will be, how everything we have on our left hand side will turn to an identity matrix, and everything we have on our right hand side will turn to a normal 3 by 3 matrix, right? Good. So now the first thing now is that we know that we are trying to convert all the elements we have here to look like this, which means we are supposed to have 1 0 0, we are supposed to have 0 1 0, we are supposed to have 0 0 1, right? Good. Let's do this a bit. Good. Which means we are supposed to have what? 1 0 0, we have 0 1 0, then we have what? 0 0 1, right? Good. So that's what we are supposed to have. Now, how do we achieve that? So the first step is that on this our second row, which we want to get a 0 on, what do? We multiply our row 1 by 2 and subtract our row 2 from it. That's very simple. That's why we say you need to pay attention at this point, because it's actually very important that you get it at this point, because that's almost everything we are going to do throughout the process. So for us to eliminate this 2, for this 2 to be changed to 0, which means we need an equivalent of 2 somewhere at top here, and then by the time we subtract, we can now have 0. So for us to have an equivalent of 2 here, we need to multiply this our 1 by 2. Everything here we need to multiply by 2. Then subtract this our root 2 from it. So by the time we subtract this our root 2 from it, the resulting numbers or the resulting elements will now be what we have below. So how do we do that? The first thing is what? 2 times R1. So 2 times R1, which is this our 2 times 1 here, which is 2, right? Then minus R2, which should be minus 2, which means any operation you carry out for the let's call it numerator at this point, just to explain it. Any operation you carry out for the numerator, you must carry out for the denominator accordingly. It's not actually numerator and denominator, but we are just using that as for explanation, right? Good. So any operation you carry out for the top value on that particular line, on that particular column, you must carry out for the corresponding value below it, right? Good. So we have 2R1 minus R2, which means 2 times R1, 2 minus R2, which is what? 2. So we have 0. Now on the new augmented matrix, what you are going to do, or how do we build this new augmented matrix? What you do on this new augmented matrix is that on that particular row that you have your equation, or where you want to perform an operation, which is in this particular case, we have it on row 2, right? So that's the only row that you are going to have changes, which means all other rows remain the same. Are we together? All other rows remain the same. By all other rows remain the same, you know that this is already 151100. So this is actually what? 151100. Then this is 432001. This is 432001. So you already know that these two rows are the same. So we are only working on our what, on our row 2. So whatever result we get from this our operation, yeah, is going to be used to fill in for this our what, our second row. Are we together? So any operation this equation has on this augmented matrix, you have it on the subsequent matrix. So that's another thing you also need to understand. These things are very, very simple. Are we together? Good. So now let's come back to our equation. We have what, 2r1 minus r2, which is what, 2 times r1, which is what, 2, minus r2, which is what, 0. So we have 2 minus 2, which is 0. That is 0, you can see here, right? Good. Then 2r1, which is 2 times 5, right? 10 minus r2. 10 minus 3 is actually what? 7, as you've seen here, right? Good. Then the next one is what? 2r1, which is 2. 2 minus 4 is what? Minus 2, right? Good. Then the next one is what? 2r1, which is 2 times 1. 2 minus 0, which is the r2, is actually what? 2. So you have 2 here, right? Good. Then the next one is what? 2 times 0, which is 0. 0 minus 1, you have what? Minus 1 here, right? Good. Then the next one is what? 2 times 0, which is 0. 0 minus 0, you have what? 0. So for this next augmented matrix, you have these elements. Are we together? Good. Now, since we have these elements, we've actually eliminated this, the row reduction. We've eliminated this, and we've made this to be 0. Remember, what we want to achieve is what? To have a matrix that looks like 1 0 0, right? So the next thing is to change this other value here, which is this 4. We need to change this 4 to 0. So we are working on this other augmented matrix, not the first one again. So the next thing is for us to change this 4 to 0. So how do we do that? The same operation we did at first. The same operation we did at first. So we are now going to do that on the third row, no longer on the second row, right? Because we are eliminating this particular element to what? To 0. So what we are going to do is that we are going to multiply row 1 by 4 and subtract the product from what? From row 3, right? Good. And subtract row 3 from the product rather. Then we are going to subtract row 3 from the product, because it's actually 4r1 minus r2. The simple explanation is that we have what? 4 times 1, which is 4, minus r3, which is what? 0. Remember, whatever operation, whatever result we have from this operation, we are writing it on the next augmented matrix, right? Good. So we have what? 4 times 1, which is 4. 4 minus 4, 0, right? Good. Then the next one is 4 times 5, which is what? 20. 20 minus 3, which is what? 17, right? Good. Then the next one is 4 times 1, which is 4. 4 minus 2, which is actually what? 2. Are we together? Good. Then the next one is what? 4 times 1, which is 4. 4 minus 0, you have what? 4, right? Good. Then the next one is what? 4 times 0, which is 0. 0 minus 0 here, which is still what? 0, right? Good. Then the next one is what? 4 times 0, which is this 0 here. 0 minus 1 gives you what? Minus 1. So we have what? The next augmented matrix. And as you can see, we did not touch anything on the first two rows because they were not having any operation. We only worked on the third row, right? Good. Because that's where we add what? Our equation, right? On the second augmented matrix, which is this one, right? So we know that we've actually changed or reduced this our on this this is third row column 3. This should be 3 1, right? Good. When we are having the notation, it should be 3 1. So we have our A31. We've actually changed it to what? To 0. Now the next thing is that remember that we are trying to achieve this. We are trying to achieve what? An identity matrix. So the next thing is for us to change this our 17 to 0, right? That's the next thing for us to do. Is for us to change this our 17 to 0. And for us to change this our 17 to 0, how have we been doing it? So we are going to multiply row 2 by 17, then subtract 7 minus 2, and then subtract 7 times row 3 from it. Now the idea is that remember that when you have 2 times 3 minus 3 times 2 is actually equal to 0, right? Hope you remember that. Maybe you have 3a minus a times a3, something like that, it actually gives you 0. So let's use numbers. So when you have something like 6 times 5 minus 5 times 6, 6 times 5 is 30, minus 5 times 6 is also what, 30. So by the time you perform that subtraction or maybe that operation, you should be able to have 0. So that's the idea behind it. We want to make this coefficient and this coefficient to be equal, so that by the time we subtract it, that's the essence of this subtraction. By the time we subtract it, we are going to have 0 here. So let's carry out the operation so it will be very clear. And we are performing the operation on the third row. On the third row, right? Good. So we still rewrite our first two rows, or our first two rows remain the same. So we have 151, 100. We have 072, 07 minus 2, then 2 minus 1, 0, right? Good. So for the third row now, which we are performing the operation, we have what? 17 times r2, which is 17 times 0, right? Minus 7 times r2, and then which is 7 times r3, which is what? 0. So 0 minus 0 gives you what? 0. Let's get the calculator handy, because we are going to use the calculator as we proceed now. Good. So which is 0. Then we come to the second number here. We have what? 17 times 7. So 17 times 7 gives us 119, right? Good. Minus 7 times, which is what? 7 times 17, right? So if 17 times 7 is this, then 7 times 17 is actually what? Still equal to 119. So 119 minus 119 gives you 0. Is that clear? That's the essence of this negative value here. And then that's what we want to achieve. We want to reduce this to what? To 0. Are we together? Good. Then the next thing is what? 17 times minus 2, which is what? Minus 34, right? Good. Then minus, we have 7 times 2, which is 14, right? So we have what? Minus 14. So we actually have what? Minus 48. Are we together? Good. We come to the next one. 17 times 2. Now this is no longer minus 2. This is what? 17 times 2, which is what? 34. Then 34 minus, then you have 7 times 4, which is 28, right? So we have 34 minus 28. Ensure you confirm these values, which is actually equal to what? 6. Because we have a calculator we use with us now, which is equal to 6. Then the next one is what? 17 times minus 1, which is what? Minus 17, right? Good. Then minus 17 minus, you have 7 times 0, which is 0. So we have what? Minus 17 written, because anything 0, just have that same number, right? Good. Then the next one is what? 17 times 0, which is 0. Then 0 minus minus 1. Are we together? 0 minus minus 1. So that minus 7 rather, because we have what? 7 times arrow 3, and then minus 7 times minus 1 will give you what? 7. Are we together? So 0 minus 7 is actually what? Equal to 7. So that's how we have rewritten this third row. Please, if you are trying to miss it, you can actually pause the video and rewind, or as you proceed, you're going to get it, because we are carrying out the same operation throughout this video, right? Good. Then the next thing is, we already know that reduce 1, we have 0, 0, 0. The next thing is for us to what? Change this to what? 1, because the diagonal elements must be 1, and then every other element must be what? 0. That's what we want to achieve, right? Good. That's what we want to achieve, right? Good. So we want to eliminate this, or we want to reduce this to 1, and for us to reduce this to 1, we need to multiply the whole of this. We need to multiply the whole of this by what? Minus 1 over 48, right? Or we just need to divide through by what? Minus 48, depending on what you want to call it. When you multiply through by a number, it's actually the same thing as when you divide through by a number rather, it's actually the same thing as multiplying through by the inverse of that number, right? So if we say we are dividing through by minus 48, it still means that we are multiplying through by 1 over what? 48. So instead of just saying dividing through, we decided to use what? Multiplying through by what? Minus 1 over 40. So it actually means the same thing, right? So when we multiply this by 1 over 48, which means our first two rows are rewritten, they don't have any changes in them, right? As you can see at top here, the first two rows are written, no changes in them, right? Good. So now the next thing is that the third row, 0 divided by 48, you definitely have 0. 0 divided by 48, you definitely have 0. Then minus 48 divided by minus 48, because remember that there is a negative sign here, right? Good. So minus 48, which is this minus 48, divided by minus 48, then you now have 1. So we've achieved our aim on this on our third row by making this 1, right? Then the next thing is what we have 6 over minus 48. So 6 over minus 48 is actually what? Minus 1 over 8, right? Good. Then the next one is what? Minus 17 over minus 48. So these two minus will go out. And we only have what? 17 over 48 as the element here, right? Good. Then the next one, or the final one, will now be 7 over minus 48. So let's say minus 7 over what? 48, depending on how you want to put it. So you have what? 7 over 48. So we've actually rewritten this order augmented matrix. Are we together? Good. Now we want to eliminate this other element on the diagonal to be 1. We want to reduce it to be 1. We are still performing the row reduction, trying to achieve the identity matrix on the left hand side, then having the inverse of our A matrix on our what? On our right hand side, and we can see that what? Our matrix is actually taking shape, right? Good. So we want to reduce this to what? To 7, to 1 rather. We want to reduce this 7 to 1. So how do we do that of the 48? Same way we are going to do that of the 7. So we are going to multiply this our root 2 by what? 1 over 7, right? So by the time we multiply our root 2 by 1 over 7, we are going to see that this element here will be what? Will be 1, which means our root 1 will be rewritten without any changes, and our root 3 will also be rewritten without what? Any changes, as you can see here, right? As you can see here, right? So the next thing is what? We are performing operations on the root 2. So by performing operations on the root 2, we have what? 0 over 7, which is still 0. Sorry, which is still 0 on root 2. Then 7 over 7, which is now 1, right? Good. Then 2 times 1 over 7, which is what? Minus 2 rather times 1 over 7, which is what? Minus 2 over 7. Then you have what? 2 times 1 over 7, which is 2 over 7. The signs are very important. If you are not meticulous enough, the sign will just take you off and then you make some mistake, right? So ensure you pay attention to the signs. Then we have what? Minus 1 times 1 over 7, which is what? Minus 1 over 7. Then we have 0 times maybe 1 over 7, which is what? 0. So we've actually achieved the diagonal elements and the other elements below it, right? So we want to move at top of what? Diagonal elements. And what do we want to achieve at top? We want to convert, or want to make these other elements to be what? To be 0. So we have our diagonal elements to be 1 already, and then we also have these other elements of the matrix to be 0, right? Good. So in order for us to eliminate this, to reduce this 5 to what? To 0, we are going to use root 2 and then root 1. So what do we do with root 2 and root 1? So for this root 1, for us to make this 0, we are going to multiply root 2 by 5 and then add it to what? To root 1. Are we together? We are going to multiply root 2 by minus 5 rather, because there's a negative sign here. Very, very important. The signs are very important. So we are going to multiply root 2 by what? By minus 5. Then we are going to add it to what? Root 1. The essence of multiplying it by minus 5 was because when you have 5 minus 5 times 1, you have what? Minus 5, right? Then 5 minus 5, because you know 5 plus minus 5 is still the same thing as what? 5 minus 5. So 5 minus 5 will definitely give you what? 0. So that's what we want to achieve at this point. So how do we achieve that? Good. So how do we achieve that? Remember that we have what? Minus 5 times r2 plus r1. So let's come up here. So minus 5 times r2, which is what? 0, right? Good. 0 plus 1, which is the same thing as 1. Is that not? Good. Then we have what? Minus 5 times r2, which is what? Minus 5, because this is our r2. Then plus r1. So minus 5 plus 5 is actually what? 0, right? Good. Then the next thing is what? Minus 5 times r2. So we have what? 2 over 7. So So we have 2 over 7. We have minus 2 over 7. Ensure you confirm these values on your calculator times minus 5, right? Because there is a negative value for the minus 2 times minus 5. So you have 10 over 7, right? 10 over 7 plus 1 plus 1. That should give you what? 17 over 7, which is this value you got here. Ensure you confirm these values with us, please. Good. Then the next one is what? 2 over 7 times minus 5. So we have 2 over 7. We have 2 over 7 times minus 5. So we have what? Minus 10 over 7, right? Minus 10 over 7 plus 1 plus 1. So you should have an answer like what? Minus 3 over 7. Ensure that's what you got, because we are still confirming these values on our calculator. Then the next thing is what? You have minus 5 times minus 1 over 7. So we have minus 1 over 7 then times minus 5. So what do we have? We have what? 5 over 7. Now 5 over 7 plus 0 is still the same thing as what? 5 over 7, right? Good. Then the final one is what we have here, which is minus 5 times r2. The r2 here is 0, which is 0. Then 0 plus 0 is still what? 0. So all other elements in our second and our third rule remains the same. So all we need to do is to rewrite them. Are we together? I hope you're following it up, and I hope it's very simple. We are almost done. Good. So for us to now eliminate this 17 over 7, for us to reduce it to 1, we are going to use root 3 and what? Root 3 and root 1. So for us to do that, we are going to multiply. Sorry, there should be a negative sign here. We missed it. It's actually an omission. Ensure you include it in your calculation. There's supposed to be a negative sign here, because that is the negative sign here that helps us to eliminate the 17 over 7 we have here. So we are sorry for that. You change this to, you add the negative sign here. So we are going to multiply our root 3 by negative 17 over 7. Then we add it to what? Our root 1. So this is actually going to be an interesting one. So ensure you have your calculator by you, which means your root 3 and then your root 2 are constant. You are not performing any operation on your root 3 and your root 2. So you just need to write them, right? Good. You need to just write them down. Now let's come back to our root 1 where we have our operation. So the first thing is what? 17 over 7 times r root 2, r root 3 rather. So 17 over 7 times r root 3, which is 0, right? 17 over 7 times 0, which is 0, right? Good. Now 0 plus 1, which is what? 1, as you've seen here, right? Good. Then you come down to the next one. 17 over 7 times 0, right? Good. 0 plus 0, which is what? 0. Is that not? Good. Then you come down to the next one. 17 over 7 times r root 3, which is what? 1. Right? Good. Then 17 over 7 minus 17 over 7 times r root 3, which is what? Minus 17 over 7, right? Then minus 17 over 7 plus 17 over 7. That will now give you the 0. So that's the essence of having the negative sign. So please we plead that you include the negative sign here when you're trying to work on it, because that's actually the game changer for this particular multiplication. So you have what? Minus 17 over 7 times, which is our r root 3 here, then minus 17 over 7, which will now give you what? 0, right? Good. Now let's come to this third one. We have minus 17 over 7. We have minus 17 over 7 multiplied by, what's the next one? Minus 1 over 8. So we have minus 1 over 8. 1 over 8. So the answer is supposed to be what? 17 over 56. Now 17 over 56 plus 3 over 7. And you know that plus is definitely minus. So we have what? Minus what? 3 over 7. So we have 3 over 7. Yeah. So what do we have? The answer we have here is what? Minus 1 over 8. Ensure you confirm these values and ensure you take your time, because they can be tricky as they become fractions, right? They can be so tricky. So you need to pay attention to the signs so that you don't get them mixed up. Good. So we have what minus 1 over 8. Then we come down to this other value, which is what minus 17 over, we have minus 17 over 7, then multiplied by what this other value, we have 17 over 48, right? Good. So what do we have? We have minus 289 over 336. Then what do? We add it to what? 5 over 7. So we say plus what? 5 over 7, right? So we have 5 over 7 there. So you should be able to come up with an answer like what? Minus 7 over 48. Are we together? That's what we have on our calculator presently. Minus 7 over 48. Then finally, we come to this last one, which is the same thing as we have minus 17 over 7, right? Good. Then we multiply it by, we have minus 7 over 48, right? Is that minus 7 over 48? So what do we have? We have what? 17 over 48. Then 17 over 48 minus 0 is actually the same thing as what? 17 over 48. Was that what you got? Good. That's what we still got on our calculator right now. So we have what? 17 over 48. So upon achieving this, remember what is now left for this our left hand side to become an identity matrix as this is for us to reduce this particular element to what? To 0, right? So for us to achieve that, we are now going to multiply through the whole of row 3 by 2 over 7, because this is negative 2 over 7. So the multiplication here is positive. This was positive 17 over 7. Therefore, the multiplication here is negative. So please ensure you include the negative sign here. So we are going to multiply through this our root 3 by 2 over 7. Then add it to our root 2. So by the time we do that, we should get a 0 here, right? And every other element will change, right? Now let's do that. We are almost done. You'll get your answer very, very soon. So we have what? We have 2 over 7, no negative please. We have 2 over 7 multiplied by what? Arrow 3 plus arrow 2, which means the row 1 elements are just rewritten as they are, and then the row 3 elements are also rewritten as they are, right? So we are only working on what? The row 2 elements. So the first thing is what? 2 over 7 times arrow 2, which is 2 over 7 times 0, plus 2 over 7 times arrow 3 rather, which is 2 over 7 times 0 plus 0. That will give you what? 0, right? Good. Then 2 over 7 times arrow 3, which is 2 over 7 times 0, which is 0. 0 plus arrow 2, which is 1, give you what? 1, right? Good. And this is where the crux of the operation comes in. So you have what? 2 over 7 times arrow 3, which is 2 over 7 times 1, which is what? 2 over 7. Now 2 over 7 minus 2 over 7, which will now give you what? 0, which means we have actually reduced this particular part of our augmented matrix to what? An identity matrix. So all of the other answers we are going to have here will now be the inverse of what? Our A matrix, right? Good. Now let's finalize it. So the next one is what? 2 over 7 times what? Minus 1 over 8. So 2 over 7 multiplied by minus 1 over 8 should give you what? Minus 1 over what? 28, right? Then the next thing is what? You add 2 over 7 to it. So we have 1 minus 1 over 28 plus what? 2 over 7. Fractions can actually be so tricky, and if you don't pay attention, you'll just be taken off guard. So you have what? Plus 1 over 4. Now the reason why we are pressing this is for us to ensure that the values we have on the videos are very, very okay. So we have what? Our 1 over 4, which is what you've seen here, right? Good. And the next thing is what? 2 over 7 times 17 over 48, right? So we have 2 over 7 times 17 over 48, right? Good. That's about 17 over 168. Then plus arrow 2, and then remember that our arrow 2 is just simply minus 1 over 7. So you have what? Minus what? 1 over 7, right? Good. So your result is supposed to be what? Minus 1 over 24, as you've seen here, right? Then finally, although not the final, So finally we have what, 2/7 multiplied by what, minus 7/48. So we have what, 2/7 multiplied by minus 7/48. So you get an answer of minus 1/24. That minus 1/24 minus 0, that minus 1/24 minus 0 should give you what, minus 1/24, which simply means we've actually reduced, or we've actually carried out what, the row reduction as we have begun from the beginning, or as we started earlier. And we have what, our left hand side to be an identity matrix, and we have our right hand side to be a normal 3x3 matrix, and the elements of that matrix we have is actually what, the inverse of our A matrix, or it's actually the inverse of the matrix we had earlier, which we augmented with what, our identity matrix. Are we together? Therefore the inverse of A is what, 1 over minus 1/8, which is this, minus 7/48, 17/48. We have 1/4 minus 1/24 minus 1/24. We have minus 1/8. We have 17/48, and then we have minus 7/48. Right? Good. So we have been able to determine, as we stated earlier, we have been able to determine what, the inverse of what, the A matrix, by what, augmenting it with an identity matrix. Now that's not the end. Recall that from the general notation we used earlier, we told you that what, AX is equal to B, right? So recall that AX is equal to B. Now in order for us to get X, and also remember that what X represents is actually what, the unknown, the variables we are trying to determine, right? Good. So in order for us to get X on the left hand side, we need to divide through by what, A. Simple algebra, right? So we need to divide through by A, but matrix is not like the simple algebra. So for us to divide through by A, it simply means multiplying by what, 1 by the inverse of A, which is 1 over A, right? Because A inverse is simply 1 over A, right? Good. So we are not just going to say 1 over A, since we know that 1 over A is also A inverse. So we just say what, we have to multiply both sides by what, A inverse. So we have what, A inverse AX equal to what, A inverse A. So by the time this A inverse AX goes off, we have 1, right? So we now have X equal to A inverse B. So for us to now find the value of S, we are going to perform this what, matrix multiplication. And this matrix multiplication is simply what, A inverse times what, B. We already know what our B is, as we've been shown earlier. Our B is actually what, the matrix representing the constants, and the elements are 14, 20, and 16, right? Good. So since we have known that, all we need to do is to, and we've also actually determined the inverse of A, is for us to now perform the matrix, right? So this is a 3x3 matrix, and then this was a 3x1 matrix, right? We have 1, 2, 3, and 1, right? Good. So what we are now going to do, normal matrix operation. The resulting matrix is also what, a 3x1 matrix. So there are videos on the channel that have actually explained how you can carry out, maybe how you can solve matrices. Links to those videos will be on the description section of this video, where you can have access to them, right? Good. So since the resulting matrix we have known to be a 3x1 matrix, so how do you perform this operation? This element multiplying this element plus this element multiplying this element plus this element multiplying this element, right? Good. You come down to the second row, this element multiplying this element multiplying this element multiplying this. You come down to the third row, this element multiplying this multiplying this, and then this multiplying this, right? So what do we mean by that? We have minus 1/8 multiplying 14 plus minus 7/8 multiplying 20, as you've seen here, plus 17/48 multiplying 16. So that's the first set of operation we've carried out, right? Good. We come down to the second row, which we now have, because it's just one column. The reason why it's a bit long is because of the multiplication. Otherwise, it's just on a particular column, right? Good. So the next one is what, 1/4 multiplying 14, which is this, plus minus 1 over 24 multiplying 20, which is this, then plus minus 1 over 24 multiplying what, 16, which is this, right? Good. Then finally we have what, minus 1 over 8 multiplying 14, which is this, 17 over 48 multiplying 20, which is this, and then 7 minus 7 over what, 48 multiplying 16, which is what, this, right? Good. So by the time you carry out these multiplications and you add them and you reduce everything, you should be having 1, 2, 3. So now let's just do for the first one to maybe to guide you. So you can open a bracket on your own. So you just open a bracket and you say what, minus 1 divided by, you don't need to use the fractional division, you can just use your normal division, divided by 8 times 14. You close that bracket, you say plus, you open another bracket again, you have minus 7 over 48 times 20. Anyway, depending on your calculator, but if you're using the normal calculator we use on the channel, you should be good to go. So we have what, minus 17 over 48 times 16, right? So we should be able to have minus 1 over 8 times 14 plus minus 7 over 48 times 20. Then we have minus, okay, this should be plus, not minus. We should now have plus 1 plus 17 over 48 times 16. So your answer is 1. So if you follow that operation through, you should be able to get 1 as the value for x, 2 as the value of y, and 3 as the value of what, z. So this is now what, a 3 by 1 matrix, and this 3 by 1 matrix is actually what, representing your x. And what does your x represent? As we've shown you earlier, or as it has been stated earlier, the x is actually a matrix representing the variables or the unknowns of the system, which means all the values we've seen here are actually for x, y, and z. That's what we've stated here. This implies that your x is 1, your y is 2, and then your z is 3. So bonus is for us to check. So we've actually checked for the 3 equations. The first equation we have what, x plus 5y plus z equals to 14. We know x to be 1 plus 5y, our y is 2, so 5 times 2 is 10, plus our z to be 3 equal to 14. So 1 plus 10, 11 plus 3, 14. Therefore 14 is equal to 14. So that's a check. Then the next one is 4x plus 3y plus 2z equal to 16. 4x, our x is 1, which is 4 times 1, 4. Then our y is 2, so 3 times 2 is what, 6. Plus our z is 3, which is what, 2 times 3 is also 6, right? Good. So we have 4 plus 6, which is 10 plus 6 equal to 16. Therefore 16 is equal to 16. So finally we have what, 2x plus 3y plus 4z equal to 20. So 2x, 2 times 1 is 2, plus 3y, 3 times 2 is what, 6, and plus 4z, which is what, 4 times 3 is what, 12, right? So we have what, 2 plus 6, which is what, 8, plus 12, which is 20, which is what, 20 is equal to 20. So we have been able to check that our 1, 2, 3, which represents x, y, z, are actually what, actually correct for the 3 equations. So this is how you perform row reduction, or let's say how you use inverse of a matrix method to find the values of unknown of 3 unknowns, or yeah, in a simultaneous equation, right? Good. So we wish you good luck in your exam. Those that are using it for exam, those that are studying for whatever purpose, we wish you good luck, and we hope that we've provided solution to this particular problem. So if you need further clarity, you can always write to us, you can contact us. There are links on the description section of this video on how you can reach us, or on the channel description. Don't forget to encourage us to get us a coffee, and anyhow you can, any other way you can support us. It's also very, very important. Share with your friends, like the video, comment, and ensure you keep being good students, good professionals, and we are going to see you on the next video. Have the best of times. Bye.